They say a man's best friend is his dog. For a girl, it's a diamond. It smells better, lasts longer, and doesn't chew your slippers. Given how hard it is to find and mine diamonds, it's no surprise they cost a fortune. But it seems we may not be mining diamonds for much longer, because now they've found a way to grow them in a laboratory. So, how do they do it? Sunny Florida, USA. Famous for palm trees, luxury retirement homes, and those great Art Deco buildings. But few people realize that it's now also one of the world's diamond capitals. That's because in Sarasota, a company called Gemesis has come up with a way to artificially produce these rare stones. It looks like something out of Alien. There are very few people here, just row upon row of machines that look like growth chambers. In fact, they are growth chambers, but they're not gestating giant alien bugs. These machines are busy making diamonds. Every day on this high-tech production line, Chris Owens oversees the sowing and harvesting of up to 40 rare gems.
Every day's a new battle, you know, every day's learning something new.
In nature, a diamond is formed when, say, a tree is torched by a volcano and then crushed beneath the Earth's crust for millions of years. In here, the process begins when Chris loads the machine with what he calls a seed. This seed is actually itself a tiny diamond, and it's placed in a capsule containing graphite. The idea is to melt this graphite at 2,700 degrees Fahrenheit and cause it to reform on the surface of the diamond seed. To imitate the force of a mountain, they need to generate more than 58,000 times normal atmospheric pressure. To do this, they use 6 chunks of alloy, called anvils, which form a tight-fitting cocoon around the graphite. This cocoon is then sealed with 8 steel wedges.
It's just like taking a mountain and setting on top of it. Immense amount of pressure, immense amount of heat.
The design of this growth chamber has taken 50 years to perfect. In the early days, it was hard to create enough pressure, and the machines had a habit of blowing up. These days, the units are closed with a hydraulic ram before massive steel lock rings seal the machine shut. As the pressure and temperature builds up inside, the graphite begins to melt, turning it into a superheated liquid. Carbon atoms then begin to attach themselves to the diamond seed, gradually building up on its surface layer by layer. It's a slow process. It's also hit or miss. Not every seed will turn into a proper diamond.
One thing missed and we have no diamond. And the machine will run just the same for 4 days. We'll unload it, empty, nothing.
4 days later, it's time to harvest the diamonds, and Chris carefully opens each machine. To find out whether it's worked, they need to remove the casing. First, the outer ceramic layer is simply broken away with a gentle tap from a hammer. But the inner metal casing needs to be removed more carefully, so it's added to a flask of hydrochloric acid, which dissolves the metal. After 5 hours in the acid, the metal capsule has been eaten away. This one is a success. In only 4 days, the graphite has been transformed into a diamond. Gemesis specializes in producing yellow diamonds, which are highly valued on the market. Each one is carefully weighed, checked for flaws and clarity, and added to the pile, which is shipped every week to New York. Every year, billions of dollars worth of diamonds arrive here in Manhattan to be cut, graded, and sold. But cutting a diamond is no easy task. It is, after all, the single hardest natural substance there is. So to cut a diamond, you need a diamond. This time in the form of a powder, which is used to coat these turntables. It's a highly skilled job, And here at Solara, they spend days working on each stone. They want to produce a symmetrical stone, but they don't want to cut too much away, and they can't cut against the grain. So each diamond has to be cut into a slightly different shape. Once the diamond cutters have finished their work, all that remains is for the diamond to be certified. That happens here at the International Gemological Institute. Gemesis diamonds are just as real as the ones that form naturally under volcanoes. To tell the difference, you need an expert like David Weinstein and a powerful binocular microscope. So, how does he tell them apart?
The color in the stone, being a very intense orange, tells me that this is likely to be a laboratory-grown stone, and the microscope allows me to see the microscopic characteristics inside that help me identify it.
To confirm their origin, all lab-grown diamonds over 1/4 carat are etched with a laser. With this little bit of handiwork complete, the finished stone is ready to burn a hole in the pocket of some guy and to decorate the finger of some doll. But what takes nature several million years now takes modern science just 4 days. These man-made diamonds cost about 1/4 the price of the regular kind. Not that there's any need to tell your special lady.